My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 233. In this lecture, we will try to understand visualize MNIST dataset, that is visualization of MNIST dataset. I already discussed this MNIST dataset in my previous lectures. I request you to refer lecture number 221 and also lecture number 222. In these two lectures, I discussed about this particular dataset where we visited Christopher Ola's blog. This is Christopher Ola's blog. In this blog, we discussed in detailed manner of this particular dataset. We were saying that there are digits 0 to 9. How many class labels? There are 9 class labels like this. We discussed neatly about this particular dataset. I kindly request you to go through that two lectures before understanding this lecture. So let's look at our MNIST dataset. MNIST dataset, what is our dataset name? Our dataset name is MNIST dataset. MNIST dataset. Now this MNIST dataset, how many dimensions does it have? It is having 784 dimensions. Visualizing these many dimensions is very difficult. In that case, what we have to do? We have to apply principal component analysis. After applying, this can be converted into 2 dimensions. We can say we are broken. I can say we are back on Christopher Ola blog here, which I discussed in my lectures, lecture number 221 and 222, isn't it? Just again I am requesting you to go through that two particular lectures. What they have done, they have taken these 784 dimensional data set. They have computed for this one, for these 784 dimensions, what they calculated PCA, and they projected it to top 2 eigenvectors. 2 dimensions means what? They calculated top 2 eigenvectors V1, V2. I already discussed how to calculate these top 2 eigenvectors. If you want, just there is anyway I will show you cola dot this link. Just refer this link for this visualization. Cola dot github .io 2014-10. Just otherwise I will show you after a few seconds what they calculated. They calculated top 2 eigenvectors, isn't it? This is direction of, I can say, let me say like this. This is direction of my first top eigenvector, first V1. This is as 784 dimensions is projected into 2 dimensions with the help of this top 2 eigenvectors. This is direction of V2. This is direction of V1. This is direction of V1. This is direction of V2. And as usual, just like raw data, each of these points, just like raw data, each of these points corresponding to one value, and they are colored. So one value in the sense that what are the class labels here? Your class labels are 0, 1, 2, so on 9, isn't it? They are colored. These these are colored. They are colored. So different for different numbers, they have colored different colors, isn't it? So what our yi is? This is yi 0 to 9. So this color coding helps us to understand how well this dimensional reduction has worked out. Now, by seeing this color coding, you can understand how well this dimensionality reduction has worked out, or whether it has worked or not. Let's look at it. So these red points these red points are, let me otherwise just wait for 1 second. I will go to that particular website and I will show you. Just see this one. Just see this one. These red points, let me see. So all these red points are 0. Just see all this. Just see here you are getting corresponding number. This red points are zeros. These red points are zeros. Just see. All these red points are zeros. Just see this one. What about this one? You see here these red points are zeros. These red points are zeros. The brown points all just see these brown points all your ones. Just see all your ones. Here you have zeros. Here you have zeros. Here you have ones. So one thing that you quickly notice is all your zeros roughly in this region. Just see all your zeros roughly in this region, isn't it? These are all your zeros region, isn't it? All your ones roughly in this region, if you carefully observe it, isn't it? Now comes the hard part. So ones and zeros are fairly well separated. Just see, zeros are here and ones are here. They are fairly well separated. As the dimension of this particular data set is 784, it is difficult to visualize 784 dimensional data. What we did, we converted into two-dimensional data. How we, as I told you, how I converted, computed PCA, you got V1 and V2 and projected all the data onto V1 and V2. These V1 and V2 are top two eigenvectors. One thing that you quickly notice is that all zeros are grouped together. Just see, all zeros are grouped together and all ones, just see here, and all ones are also well grouped together. But for rest of them, it's still not very clear. For example, if you see these light green points, just see these light green points. Yes, these light green points. If you see these light green points here, these points at twos are separated, twos are spread all over the place. Just see, twos are spread all over this particular place, isn't it? So twos are not well separated. So why am I telling you that well separation is important? In machine learning algorithms, well separation is very important. Problem is PCA is a weaker dimensional reducing algorithm. It's not best algorithm, by the way. It's actually one of the simplest algorithm, probably one of the oldest technique I know for dimensionality reduction. This I can say it is the oldest technique. This is the output of dimensionality reduction after applying PCA on 784 dimensional data to get to see a two-dimensional visualization. Here what is our difficulty? Like this number 2 is spread all over this place. It is plain all over this system, but they are not well separated like zeros and for example here zeros are well separated with ones. Just see here ones and zeros are well separated, but other numbers, they are not that well separated. That's the biggest difficulty with the principal component analysis. Just go through this lecture. Of course, principal component analysis has got its own significance. We will keep on using these algorithms in different situations. I will discuss about it. We will try to understand limitations of PCA in my next lecture, that is in lecture number 234. Just go through this lecture. This lecture is very important in understanding dimensionality reduction. Thank you very much.